Hello, I'm Dr. Jeremy Glissen Brown, Assistant Professor of Gastroenterology at Duke University Medical Center.
And my name is Dr. Sanjay Gadi, a third-year internal medicine resident at Duke University. We're pleased to discuss our paper recently published in GIE titled Creating a Standardized Tool for the Evaluation and Comparison of AI-Based Computer-Aided Detection Programs in Colonoscopy, a Modified Delphi Approach.
On behalf of all our co-authors, we'd like to thank GIE for the opportunity to share our work as part of this author interview series.
Multiple computer-aided detection, or CADD systems, have now achieved regulatory approval in the US, Europe, and Asia, and are being used in routine clinical practice to support colorectal cancer screening. However, there has not been a standardized approach to evaluating and comparing the performance of CADD systems. This lack of consensus on what metrics to prioritize for assessment was what inspired us to perform this study.
Our primary aim was to identify high-priority metrics for evaluating CADD performance in a standardized way. Importantly, the focus of the study was on developing these metrics for in silico testing using benchmark video datasets, allowing for direct, objective comparisons between emerging and existing CADD algorithms.
By doing this, the study sought to establish a framework that can help guide future research and the ongoing development, assessment, and potentially regulation of CADD technology, ensuring that the systems used in clinical practice are as effective and reliable as possible.
In terms of thinking about what this study adds to the medical literature, it's the first of its kind to use a modified Delphi approach to establish international consensus on priority criteria for evaluating CADD systems. Using this methodology, we gathered input from 25 experts in AI and gastroenterology spanning 12 countries and 5 continents, including clinicians, researchers, and industry representatives, to identify the most important metrics.
Through this iterative consensus building process, we identified 6 criteria that are now considered the highest priority for evaluating CADD systems. These include sensitivity, separate and independent validation of the algorithm, adenoma detection rate, false positive rate, latency, and adenoma miss rate.
These 6 criteria balance that needs to be struck between improving detection with sensitivity in ADR while minimizing false positives that could lead to unnecessary intervention. The prioritization specifically of sensitivity in ADR aligns with the primary goal of CADD systems, improving the endoscopist's ability to detect lesions early without overwhelming them with false alarms.
Additionally, we clarified how these metrics should be defined, particularly around statistical measures like sensitivity and false positive rate, to ensure that they are consistently applied across future studies. This is crucial for future comparisons and for developing objective tools to assess CADD systems in practice.
While this study has made significant progress, there are still several key steps to take before these criteria can be widely implemented. One key next step is for our identified metrics to be validated using benchmark video datasets to develop a standardized scoring instrument. This might then be used across institutions, research settings, and regulatory bodies. Such an instrument would provide an objective framework for evaluating and comparing CADD systems, enabling more consistent approval processes among hospital systems, GI societies, and regulatory authorities such as the FDA. This would also help accelerate the adoption of effective CADD technologies in clinical practice.
Additionally, as CADD systems continue to evolve, it will be important to periodically update the evaluation criteria. AI technology, particularly in healthcare, is advancing rapidly, and new algorithms and capabilities will likely emerge. Therefore, ongoing refinement and adaptation of the scoring criteria will be essential to keep pace with these developments.
In conclusion, this study was conducted to address the lack of standardized metrics for evaluating CADD systems in colonoscopy. By identifying and prioritizing key criteria, we've laid the groundwork for objective assessment of AI-based technologies in CRC screening involving key stakeholders and experts in this field. This is an important step toward ensuring that systems are both effective and reliable tools for improving colonoscopy quality and ultimately reducing colorectal cancer mortality and morbidity.
Looking forward, future research will focus on validating these criteria, developing standardized scoring instruments, and ensuring that we can continue to evaluate and compare emerging CADD technologies as they evolve. Thank you.
Thank you.